Welcome to our today's lesson. This is Million Kambuli Jr. Today we are going to look at the periodic table. The periodic table. Others call the periodic table the Bible of chemistry. Okay, the Bible of chemistry. It is important to know the periodic table for you to enjoy chemistry. By definition, the periodic table, the one you are seeing on the screen, is a table that shows elements in order of their increasing proton or atomic numbers. Okay, I'm sure you remember when we were dealing with the atomic structure. I made mention that that every atom is in the form X, then A, B, where A is the mass number, okay, the mass number or nucleon number, and then X is the chemical symbol of the atom, chemical symbol, and then the number down here is called the atomic number, but you can also call it the proton number. Okay. Now, I just said that the periodic table is a table that shows elements in order of their increasing atomic numbers. So what we are saying is that on the periodic table, this number here, the number down, they are shown in their order. Okay, observe with me. For instance, hydrogen is number 1. Okay, then we come to helium. Helium is number 2. Then we have lithium number 3, beryllium number 4, boron number 6, carbon number 7, nitrogen number 8, oxygen number 9, fluorine number 10, fluorine number 9, neon number 10, and then sodium number 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18. So as you can see, the atomic numbers or the proton numbers are in order. Unlike the mass numbers, observe the mass numbers. Hydrogen has got 1, sorry. Hydrogen has got 1. Then helium has got 4. Lithium has got 7. Beryllium has got 9. Boron has got 11. Carbon has got 12. Nitrogen has got 14. So the mass numbers are not in order. The mass numbers are not in order. But the atomic numbers or the proton numbers are in order. So the periodic table is a table that shows elements in order of their increasing atomic numbers. So that's the definition of a periodic table. The periodic table has got what we call periods and groups. It has got what we call periods and groups. Okay, so what are periods? So periods are the horizontal rows. Allow me to erase these. So periods, these are horizontal rows of the periodic table. Okay, there are periods. For instance, this is the first period. The first period has got hydrogen and helium. And then this is the second period. The second period has got lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. And then this is the third period, and so on. Okay? So we have, this is period 1, period 2, period 3, period 4, period 5, period 6, period 7. Okay? So these, we call them periods. The horizontal rows of the periodic table. Okay? But apart from periods, the periodic table has got rows, or has got groups, sorry. It has got groups. It has got groups. Okay, groups. These are vertical. These are vertical columns of the periodic table. Okay, the vertical columns of the periodic table. So for instance, we have group 1. So this is group 1. This is group 1. This is group 2. And then there's a gap between group 2 and group 3. So we have this one here is group 3. It says group 3. It says group 4. Okay. So as you can see, groups are vertical columns of the periodic table. Okay. And we have 8 groups on the periodic table. So we have group 1, group 2, group 3, group 4, group 5, group 6, group 7, then group 8 or group O. Okay. So it is very important to take note of that. Okay, so allow me to explain something with regard to what determines the group of a periodic table. Okay, what determines the group of a periodic table? Yeah, so okay. So elements in the same group contain the same number of electrons in the outermost shell. Okay, so that is very important to take note. Elements in the same group contain the same number of electrons in the outermost shell. For instance, group 1, these are elements in group 1. Group 1, we have lithium. So we have lithium. So lithium, the atomic number is 3. So let us draw the electronic configuration of lithium. So the first shell will have 2. Then the last shell to reach 3 will remain with 1. So lithium has got 1 electron in the outermost shell. Hence it is found in group 1. So all the elements in group 1, they've got 1 electron in the outermost shell. So lithium, we have 2, then 1 outside. Even sodium, look at sodium. So sodium, the atomic number is 11. So sodium, the atomic number is 11. So the first shell will have 2 electrons. The second shell will have 8. So 2, 4, 6, 8. 2 plus 8, that's 10. To reach 11, the outer shell of 1. So we have 2, 8, then 1. So sodium has got 1 electron in the outermost shell, hence it is placed in group 1. Okay? Even when you come to, for instance, group 4, we have carbon, atomic number is 6. So say carbon atomic number is 6. First shell will carry 2 electrons. The second shell will have, so we've written 2 to reach 6, you're remaining with 4. So 2, 4, okay? So we'll have 2, then followed by 4. And since the outer shell contains 4 electrons, it follows that carbon is in group 4, okay? It is in group 4. So the number of electrons in the outermost shell determines the group of an element on the periodic table. Let us go to periods. What determines the period of an element on the periodic table? What determines the period? Okay, so the period of an element on the periodic table is determined by the number of shells. Okay, it's determined by the number of shells. For instance, for example, calcium atomic number is 20. So the electronic configuration will be as follows. So we have 2 followed by 8. So 2 plus 8, that's 10. Then another 8. 10 plus 8, that's 18. To reach 20, we are remaining with 2 electrons. Okay. So which group of the periodic table can you, which group of the periodic table can you find calcium? So it's group 2, right? So calcium is in group 2. Why? Because it has got 2 electrons in the outermost shell. Okay, now in what period is calcium found? What period? So remember I said the period of an element on the periodic table is determined by the number of shells. So how many shells does calcium have? So we have 1, 2, 3, 4. So meaning calcium is found in period what? 4. Let us prove that. So we come to group 2. We check in group 2, where is calcium? There it is. Okay. So calcium is found in group 2, but it is found in period what? In period, so this is period 1, this is period 2, this is period 3, this is period 4. So it is found in period 4. So why is it in period 4? It has got 4 shells. Why is it in group 2? It has got 2 electrons in the outermost shell. Okay, so it is very important to know that. Okay, let us now go to special groups on the periodic table. Special families or groups of the periodic table. special families or groups of the periodic table. Yeah, so first and foremost, it is very important to take note of the fact that the periodic table is divided into two parts. So metals and non-metals, and you divide using this zigzag borderline. Okay, so you have the zigzag borderline here. So here we have, after this zigzag borderline, we have what we call non-metals. Non-metals. Then before the zigzag borderline, we have metals. We have metals. So the non-metals, they can be gases, they can be liquids, okay? But they are not metals. That is very important to take note. Then the elements like aluminium, germanium, antimony, and polonium, these elements, we call them metalloids. They are called metalloids. Metalloids. They possess both characteristics of metals and non-metals. So to avoid insulting, instead of calling them metalloids, you can also call them semi-metals, okay? They can be called semi-metals. But you need to know both terms, metalloids or semi-metals, because they possess both characteristics of metals and non-metals. Okay, then you also need to know the following important families of the periodic table, special families of the periodic table. Group 1 elements. The group 1 elements, they are special, they are called alkaline metals. Alkaline metals. Also, the group 2 elements, they are also special. They are called alkaline earth metals. Alkaline earth metals. Then, as you can see, between group 2 and group 3, we don't have a group here. And these, we call them transition metals. They are called transitional metals or transitional elements. Okay. These metals, they have high density. They also have high melting and boiling point. So why are they not placed in a group? Well, because they have no fixed valence. They have no fixed valence. They have no fixed valence. Okay. And then another special group to know is group 7. Group 7 elements. Group 7 elements are called halogens. Okay, they are called halogens. They are called halogens. Or salt producers, they're called halogens. And then group O elements, they are called inert gases, inert gases, or noble gases, inert or noble gases. Noble gases. Okay. Inert means doesn't react, so they are stable. Group O elements, they are stable. They don't react with any element on the periodic table. So they neither lose nor gain electrons. Okay. So it is very important to take note of these special families of the periodic table. Okay, so are you able to remember them, the special elements or the special families of the periodic table? the special families of the periodic table. Okay, so special families. Special families, we have group 1. And we said group 1 are alkali or alkaline metals. We have group 2. And group 2 elements are called alkaline earth metals. And then we have group 4. No, group 7. Group 7 elements are called halogens, which are salt producers. Salt producers. And then we have group O. They are called inert or noble gases. Okay, so these are special families of the periodic table. In our next broadcast, we'll consider each one of them in details. So thank you very much for your attention. Until next time, shalom.